All right, homework 10, problem 1. Lithium bromide molecule oscillates with a frequency of 1.7 times 10 to the 13th hertz. The question is, what is the difference in energy in EV between the allowed oscillator states? So if you pop over to the lecture notes, you'll find E equals N plus 1/2 HF is the oscillator equation from Planck's work. All right, so this is what we're looking at. The delta, of course, is HF. Right? That's allowed steps because n is an integer from 0, 1, so on. All right. So we have an oscillator at 1.7 times 10 to the 13th. Right? I've already stuck in h in EV seconds, which is 4.14 times 10 to the minus 15th electron volt seconds. So we're after HF. Our F is 1.7 e minus 13. Right? 1.7 e to the 13, 1.7 times 10 to the 13, right? And so HF is simply the product of those two. So 7.04 times 10 to the minus 2, right? So we're looking at delta E equals HF equals 7.04 times 10 to the minus 2 electron volts. All right, that's the answer to A. B, what is the approximate value of N for a state having a total energy of 1 electron volt? Okay, back over to Excel. Well, first, we're looking at E equals 1 electron volt, right? Equals N plus 1/2 times delta E. Right, which is N plus 1/2 times times 7.04 times 10 to the minus 2 electron volts. All right, and we're trying to solve for N. Okay, so N is 1 electron volt minus half of the delta, right, divided by the delta. So let me actually go through and do that for you on this side, all right? So I'm going to take the half times this and subtract it from the 1 electron volt on the other side. So 1 EV minus 1/2 of 7.04 times 10 to the minus 2 electron volts equals N times 7.04 times 10 to the minus 2 electron volts. All right? And so then it's clear N equals, well, put a little space in. N equals all of this put some brackets around that, divided by need more brackets. All right, so that's N. Okay, so 1 electron volt. So 1 minus 0.5 times the delta divided by the delta. So 13.7, so N is approximately 14. And that's it for problem 1.